There you go. Dude, okay, for a good minute, YouTube, I'm not gonna lie to you, I was straight up not on. I was talking for like a good, hey, Twitch chat saw it all, which is 0 people. And you know what? It's okay, we didn't really even do much. But what I was saying is, what we're gonna do today is essentially try to learn, which one are you, we're trying to learn Unity in place of Unreal Engine, and we're just doing a little practice run, to be honest. Because I pretty much know nothing about Unity, and we're gonna go in and see how much more difficult it is. And I'm also stupid too, so that's always gonna make it much harder. Let me also just make sure this is actually not stuttering, because that would be actually be stupid. Did I not go live? It says I'm live. What's this thing doing? Oh crap, I think I still have that stupid delay. Tell me I turned it off. Advanced. Stream delay, 2 seconds. Shit. I'm gonna apply it right now. Let's see if that messes anything up. Also, I'm sick, so sorry for my coughs. If we cough, don't worry about it. I'll try to mute whenever I do. It's really bad. In fact, right now, I'm gonna go ahead and drink some water real quick. I don't know why this is not going live on YouTube. Sorry, Twitch. We're trying to double it up. Let me see. Okay, we should be up again. But dude, YouTube is actually struggling so hard. This is crazy. Let's see if I can look it up real quick. YouTube. Multiple output. Instead of getting encoder settings from OBS, I sent it to NBank. Custom settings. Download the zip, it's all super easy. We're doing live actual fixes. Let's see if it fixes it. Okay. We're back there. We're back here. YouTube is not receiving enough video to maintain smooth streaming. Open widget. The stream's current bitrate is 7,000, is lower than recommended. A stream bitrate of 13,500. Listen, I set it to 1,000. I don't know why it's so poor. And it's like straight buffering on YouTube. Oh boy. This is quality content that you guys came for. I'm sure of it. Let me see. There's gotta be a way to fix this. See if I can't rush it, because it's already 2:30. And we got a lot to learn. View your channel. Oh, 1440p. Holy shit, why am I streaming at 1440p? That's crazy. That shouldn't be that way, right? Surely not. Alright, let's just hope YouTube's good. Oh god, the video is so choppy. I don't like that. I don't like that at all. I'm not trying to stream at 4040p though, that's the thing. It doesn't say. Scene get from OBS, yes. Oh shit. I wonder if it's this one. 1920 by 1080. Is that how you do it? Okay. Did it keep that? It did. Nice. Okay, we might have to restart YouTube one more time. 1920. Huh. Nice. Rock bottom. Ooh, thunder. Boom. Oh, extreme tumor. Some people are saying they're able to change it. Why am I not able to change it myself? Is it because I need it to be? Yo, this is so terrible. Alright, we're just doing tests right now anyways, it's fine. Damn, YouTube is stuck at 5 megapixels, man. Megapixels? Megabits per second. That can't be... There's no way. No, it should be higher than that. Let me check if maybe that's a YouTube thing. At... Testing my single 99. My haha is smooth. Today is a bad week to compare. Oh, this is 6 years ago. Is YouTube? No one responded to that. Great. Anytime you go to a web page, buffering is low. Alright, whatever. We'll see how bad it is on YouTube one more time after we get into like the other stuff. If it stays bad, then we can try and do something about it later. I'll do like a test stream and stuff. But for now, we should call it good and just go into our stuff. Yes. I'll see what happened. Oh wow, the stream like is only 30 seconds long. That's crazy. Damn, it looks so bad. Oh my god, I swear I'm not this much in poverty. Okay. I guess I cut it off on the YouTube one, so that's good. Alright, I'll keep this open here. Hopefully I'll get the chat still. Or if not, what I can do. Nope, I don't want to do that. There you go. Let me double check. One more thing, guys. Your channel. I should see if this is legit, if this is still working. Yo. Okay. We're back. We're so good. Yeah, okay. We're chilling. I should still be able to see the chats. Alright, it's gonna be hard with one monitor actually, low-key. We'll make it work though. Alright, good Nike. Alright, let's actually get to this, man. Let's actually do this. I wish I could minimize this, man. Get minimized. Cool. It also just doesn't go away. Oh, I can clip it here. Cool. And I can just be like, hey, stop all. Alright, that's perfect. Alright, let's go through this, man. So we're on the Unity documentation, and so we're trying to learn what the fuck a game object is. And coming from Unreal, it sounds like it's basically just an actor that you can place into a world. So game object is the base actor. You'll see here, base class for all objects can exist in a scene. Add components to a game object to control its appearance and behavior. Oh, what I wanted to look at was actually create components with scripts. Managing time, model behavior. Where did it go? I wanted to look at the components. Was that actually? I think it was in the. It was one of these ones. It wasn't tags. Create components with scripts. Component. Okay, we do one's API page. Use components. All right, introduction to components. This is what I'm looking at. What I was looking at. So components are. Minimize this. And put this here. Components are functional pieces of every game object. Components contain properties which you can edit to define the behavior of a game object. For information about the relationship between components and game objects, see game objects. To view a list of the components attached to a game object in the inspector window, select a game object in either the hierarchy window or scene view. You can attach many components to a game object, but every game object must have one and only one transform component. This is because the transform component dictates the object location, rotation, and scale. So I want to know if you can get like the relative location of a component that you can put on there. Like say there's like the main component is the game object of the player. Player has two static meshes on it. Can I get the relative location, rotation, scales of those ones? Perhaps. Every game must have one and only one transform component because the transform component dictates the game object, blah, blah, blah. To create an empty game object create empty. Select the new game object. Inspector displays the transform component with the default values. Nice. Okay. So that was the introduction to components. Wait, really, the components? Okay, so that is just its main component. All right, you can use different components to change or add functions to your game objects. You can use the inspector window to change the properties of any component, or you can use scripts, which I will open up. Because it allows you to create your own components, trigger game events, modify components, and over time respond to user input any way you'd like. All right, so that's the creating script one, which is over here, but we'll get to that. What is this one? Component. Oh yeah, that's the API. All right, add components. You can add components to the selected game object through the component menu. To add a rigid body component, select the game object and select Components, Physics, Rigid Body for the menu. The inspector displays this rigid body's properties. If you press play while you have to empty the game object selected, the Y position of the game object transform decreases. This is because the physics. Let me read that again. If you press play while you have the empty game object selected, the Y position of the game object's transform decreases. This is because the physics system in Unity causes the game object to fall under gravity. Okay, I see. Hey, let's try it. Let's actually go into Unity and try it. In fact, I have it here right here. So what did it say? Add components to selected game object through the component menu. All right, cool. Let's try it. Create. Let's use a cube. Nice. One thing I've noticed is that, okay, so this already has a mesh render and a box collider. Does it have physics on it already? Oh wow, I was already in play mode. Whoops. I didn't know you could do that in play mode. That's crazy. Just adding stuff. Play. Does it have a rigid body? Rigid body? It does not. Okay, sick. Let's try it. Cube, and we're gonna go here. How did it say to do it? Component, physics, and rigid body. Okay. Right click. Where's component? Oh, it's right there. Component, physics, and rigid body. Oh, I added it. Cool, okay. Let's not even change the math or anything. Let's just play it. Whee! We did a physics, guys! Let's go! We did something. It's not too bad. Not too bad at all. Delete. Get out of here. we need to do this better. Because I already have a plan, and we're going to go over the plan in a second. Plan essentially is, let me bring up my notes. Okay, cool. So this is the test game we're trying to make here, right? So I'm making this game for myself. I was like, okay, I just need a quick idea, and I was like, all right, to get used to like everything in Unity, because that's what I need to do essentially. Especially because I need to do it in 3 days. I'm like, all right, let's just do something really fast, so that and really basic. So I was like, okay, what's something really cool that we can do? RPGs. If you don't agree that RPGs are cool, I don't know what to tell you, man. Boom, explosion. Boom, boom, explosion. Guys, I felt like one of the AI people. I'm never doing that again, by the way. We're gonna keep it that way too. But yeah, so basically you have an RPG, and we're gonna use explosion physics to get where you need to go and also defeat enemies. So shoot your missile, and then boom, explosion. And you'll be able to like fly up or like, you know, do damage with it. So you'll have like things that can slow you down, like stacks of boxes, shoot them early, and they'll have like physics on them so you can go explode them everywhere. I was thinking maybe procedural. We'll see what we can do with that. I may or may not be able to do that in 3 days. I don't know. I doubt it. So that's just for like a little nice to have. And then also probably first person, but we might do third person to get used to like making an animation thing, just in case. So that's pretty much the plan for what we're trying to do here. And to do that, I need to learn more about what the fuck a game object is and how to add stuff and what the base components that they have, and see if we can do anything with those. And so we're gonna also try to make this in 3D, I think. That's probably the play, really, in my opinion. In my honest opinion. Boom, boom. Hope your guys' day has been going well too. PlayStation Showcase was recent too. Yesterday even. And it wasn't too bad, honestly. I was pretty excited about some games. Especially the one with, what's his name? I think Tobias Elias or something like that. Elias. He's the voice actor for Jensen in Deus Ex Human Revolution. He's in one of the new games, and I was like, oh yeah, I need to play that for sure. But, all right, let's go back to this. You can add components to the selected game object through the component menu. To add a rigid body, we did that. Okay, sick. The inspector displays rigid body properties. If you press play while you have the empty game object, the Y position decreases. The physics system in Unity causes the game object to fall under gravity. So I wonder if I'll need that in this. I probably will. I probably will be using a rigid body component. You can also add components in the component browser. Component browser. To open the component browser, select add component in the inspector. Is it just this? Like if I... Oh, it's right here. Nice. Okay. So what I also want to do is program in C#. So I'm probably going to do a create empty. But I don't know how to... Because with Unreal, all you have to do is right click here and be like, hey, okay, create. And then there's like a create in C++ thing. There's open C# project here, so I'm gonna try clicking that and see what happens. Assets, packages, scenes. No, scenes is like the levels. That's what I've gone. Tutorial info, no. .vs code, I don't think we need that. Like, I don't know what the file structure for Unity is. That's something we also need to figure out. We can see what we do with that. What we can do with that. We better not show that. Close that. Hey, listen. Hey, listen. Sample scene. Yeah, that's fine. Has a main camera, a directional light, global volume, and this game object added. So I'm gonna go ahead and delete that. So how would I go about that? It's not open C# project. Tried that. Let's go back to the documentation. This is so ADHD, by the way. It's okay. ADHD is the way we live, boys. That's how we do it. All right, component browser. So you can navigate the components by category and then browser the components by name. You can attach any number or combination of components to a single game object. Some components work best in combination with others. Rigid body works with a collider. For more information about a particular component, see the relevant component reference page. You can also access the reference page for a component from Unity if you select the help icon. Edit components. When you attach a component to the game object, the component's properties contain default values. Edit these values in an editor while you build the game, or in scripts when you run it. Two main properties: values and values and references. You can edit value properties in the inspector. These are various types of values in text, toggles, and dropdowns. For reference properties, you can drag a file for the project view into the property or use the object picker. Reference properties can reference other types of components, game objects, or assets. For more information about different property types, editing properties. Game object and audio source component. The values of audio source and component. The audio source in the inspector can show you how to adjust aspects of a component to suit your project. This actually isn't too bad. I can see it. I think once I get used to the UI, everything will be a lot easier, I think. In play mode, you can change properties of a component in the inspector. This lets you see how different values for a property affect gameplay. For example, you can experiment with different heights of jumping. Create a jump height property in a script. You can enter play mode, change the value, press the jump button, and see what happens. Then, without exiting play mode, you can change it again and see results in seconds. Yep, that's the power of scripting. The properties revert to their pre-play mode values. With this workflow, you can adjust, you can create, or you can experiment, adjust, and refine. So I wonder if you don't make game objects. You just make the components, add a game object, and be like, hey, okay, this is your stuff. But I don't imagine that being it. If a game object does not move at runtime, it's known as a static game object. If a game object moves at runtime, it's known as a dynamic game object. So we're making it I want to make a dynamic one. Can pre-compute information about static ones in the editor. Because the game object does not move, the results of these calculations are still valid at runtime. This means that Unity can save on runtime calculations and potentially improve performance. Yes. The static editor flag property lists a number of Unity systems which can include a static game object in their pre-computations. Use dropdown to define which systems include the game object in their pre-computations. Setting static editor flags at runtime has no effect on these systems. Only include a game object in the pre-computations for systems that need to know about the game object. Hold on, let me. Okay, let's see if we can digest that real quick. Static editor flags property lists a number of Unity systems which can include a static game object in the pre-computation. Use the drop-down to define which systems include the game object in their pre-computations. Setting static editor flags at runtime has no effect on these systems. Is it these ones that they're talking about? Navigation. Okay, so this is just telling like, hey, anything should GI, your occluder, your occludee, batching, navigation, like, hey, this is all static to every one of these guys. I guess like to like if you wanted to be like, hey, this could move in global illumination, which I don't know when you would do that, to be honest, but hey, maybe we'll find out. Only include a gaming object. I already read that one. Okay, so the static editor flags property is located in the inspector in the extreme top right checkbox. Everything or nothing. To set it in code, use the game object utility, set static flag, editor flags API, and the game object is static. No, okay, so we can make a game object. Dude, once I figure out how to make a fucking thing here, it's so over. I'll be like, okay. So when you enable this property, Unity includes the target mesh renderer in GI calculations. These calculations take place while pre-computing light data at bake time. The contribute GI property exposes the received GI property. The contribute GI property only takes effect if you enable a global illumination setting, such as global illumination baked, or enlighten real-time global illumination for a target scene. This tutorial is setting up for the built-in render pipeline. Okay. Reflection probes. No, what I want to do. Working with scenes. No. Where is it? Working in Unity, working with game objects. Like with Unreal, it's just a right click and you can make like a new thing. You're like, okay, hey, new guy. If I right click here, let me make a new folder. Yeah, we'll do it in assets. Come on, where's the new folder button? Dude, this is so funny. So this is basically Unreal guy coming to Unity for a second. Import package, show and explorer, get references, import, re-import, update. What's in properties? If I right click here maybe? Create. Nope, it's not there either. I might have to just show an explorer and go to assets and then say, hey, call this game objects. Did it update? Yes, it did. Create. What the fuck? Folder was right there. I'm so blind. In fact, yeah. Oh, yeah. Go ahead and delete that. Create a folder. I'm so stupid. Okay, to be fair, I feel like people would do that a lot. I feel like it should be like a immediate, like in the first page thing. Low key. Just in my opinion. So I want to do empty C# script playables. Is there just a game object? I'm guessing it's one of the script ones, but timeline, UI, build scripting. It is not here. Like I couldn't just make like a game object and be like, hey, boop, right? Is that what it's telling me? Or a game object's just the one that are actually in it? No, come on, there has to be. I should just look it up. Draw call batching. Game object fundamentals. I wanted to see what the scripts are actually. Meshes, prefabs, working with scenes. Work with multiple scenes, really? How to bake light maps? Yo. You reduce time taken to bake data and the size of generated data if you bake your data into multiple scenes. Really? Huh. To determine the brightness of surfaces in your scenes, you can bake light maps. Bake light maps or multiple scenes at once. To automate your light map builds, use the light mapping bake scene multiple scenes function. To manually bake the light maps in multiple scenes, use the Unity editor and select open the scenes you want to bake and select generate lighting. Shadows and GI light bounces work across all scenes. Bake occlusion data with multiple scenes. Go to occlusion culling window. Bake. Single asset called occlusion culling asset. In a folder matching the name of the current active scene. If you load a scene, additively, same occlusion data reference as the active scene, and the static renderers and portals that cull information for the scene, initialized from occlusion data. Occlusion system performs as if static renderers and portals are baked into a single scene. Okay, I'll come back to that. Scene templates. Unreal, Unity, I keep calling Unity Unreal, I don't know why. Think of scene template as pre-configured, a scene template as a pre-configured scene that includes all the content you want to start with. Camera and a light, that's true. Here, let's what I want to do first. Get started with scripting. Introduction to scripting. Let's do that. Unity is customizable and extendable by design. Almost everything is scriptable to some extent. Many items you can configure through the various editor views have a corresponding public C# class representation that you can interact with. By the way, guys, this is C#, by the way, just saying. You can use editor APIs to customize and extend the editor, offering tools. Really, editor API, shit, that's crazy. Preview development workflows. I mean, Unreal has it too. I shouldn't be surprised. I've used it before. Use engine APIs to define the runtime functionality of your application, graphics, physics, character behavior, and responses to user input. The scripting API reference provides a complete and authoritative reference for all public Unity APIs. Dude, I'm not gonna lie to you though. The fucking Unity docs have been so much better than the Unreal ones. I just have to say it. I gotta mention it. Sometimes the Unreal docs just do not say anything. It's crazy. But which is kind of crazier too, because they're like the more bigger, I guess. I don't know. Unity's pretty big too, actually, but having not great documentation stuff. All right, so creating scripts. Is that where I was? Where the dude? I have too many tabs open. It's already getting bad. Okay, so this is the API stuff. Lumen. What's this? NVIDIA classes. DLSS. Oh, yes. We love DLSS. Not really. I'm going to go ahead and close the API. I can just come back to it. Editing properties. I don't really need this. Okay, I know I want that one. So, tags I definitely want. Scripting API. Okay, this is the actual API. Can I color these? Come on, Edge. What do you got for me? Edge is fucking me over. Fuck Edge. God damn it. You know what? Firefox also would have done that shit, to be honest with you. Alright, introduction to scripting. Creating scripts. Alright, so since I'm already here on that one, I can close this one. Switch to scripting. In the scripting reference. Oh yeah. Base class for all objects exist in the scene. Oh, okay, wow. Oh, cool. Okay, so I'd just be like, hey, using Unity as a component. Okay, so this is pretty much what I want to do here. Type of audio source. And you can just find the audio source, or the types here. Audio clip, audio source right here. So I would use, so I need to find what, okay, so there's a couple things I want to find. So what I want to do is make a custom game object. I want to add rigid body, most likely. A movement component, like what Unreal has. If I have to make it, I have to make it. It is what it is. A mesh, not just a regular mesh, not a static mesh, a skeletal mesh, most likely. Also, that might be it, because I can also just maybe make another game object called like the RPG and have it shoot various missiles. And that shouldn't be too bad. And just have no collision on it. Oh, on the character, we also need a collision component, which is probably just the capsule. Probably gonna use a capsule, most likely. Mesh collider. Yeah, I guess they call it colliders. It might be a collider here. Dude, I'm glad that at least some of the vocabulary is kind of like coming over. That is a big help, actually. Tree transform, tree prototype. WebGL input, nice. And I also need to figure out player input UI. Just those two things. At minimum. If I can do that, I think I'll be able to just do this stuff fine. All right, hold on. Where was it? Introduction to scripts. All right. I was closing that. So mono behaviors is something I also need to look at. I don't know what mono behaviors are. You got creating scripts again. Managing time and frame rate. I will come back to that one. Splitting tasks across range. Those are actually really useful. Coroutines. I'll come back to you too. I already have it in my notes. Mono behavior again. This is something I was also looking at. This is also really important. Like when you're going to the game engine, one important things to look at is the order of execution for event functions. So with Unreal, it's usually like a whole bunch of stuff. So it goes begin play. There's a whole bunch of stuff before begin play too. I mean, just like this is like the general stuff. I wanted to find out like, hey, what's your begin play and what's your tick function in Unity compared to what our Unreal was. And for them, so they have a fixed update, but the real one that you're supposed to use, I found out, is update. And fixed update is usually like before. This is like where you're doing your physics calculations essentially. But update is more like consistent, because if you read this here, it says fixed update may happen less than once per frame at high frame rates or more than once per frame at low frame rates, kind of like that. But start is definitely begin play. I found that out. Okay, so we're going back to scripting. Actually, I should find out what a model behavior is. The model behavior class provides a framework that allows you to attach your script to a game object. It also provides hooks into useful events such as start and update. Okay, new model behavior scripts to create that. Okay, where is this? So there's the object. Wait, what's just the object? Base class for all objects that can reference in the editor. Okay, so objects are just the base class, but the game object itself is the one that can go into the scene. Okay. So this isn't, game object is an actor, and just object is your U object. That makes sense. Okay. That's just what I'm getting from this so far. Maybe not necessarily, maybe there's like one hierarchy up, but it's about what I'm getting from it. About how to understand it, essentially. Alright, where did it go? Mono behavior. Alright, I guess we're gonna come down here soon, because I'm already here. Okay. Introduction. Okay, yeah, I'm gonna get there soon. Alright, introduction to scripting. On Unity, actually, give me one second. I'm gonna go to the bathroom real quick, guys. Real fast. I will be back. All right, we're back, guys. So I promise we'll get to actual game making in a second after we figure out how to do everything. So don't stress about it. We'll get to the fun stuff soon, like making the RPG. Oh yeah, RPG. All right, let's go back to scripting, guys. We have to learn the hard, annoying, boring stuff. It's not boring to me, but we gotta learn that stuff first before we can get to the good stuff. This is how game development works. It's slow, it's messy, and yeah. All right, Unity is customizable and extensible by design. Almost everything is scriptable to some extent. Many items that you can configure through various editor views have a corresponding public C# class representation that you can interact with in code. You can use editor APIs to customize and extend the editor authoring tools to improve your development workflows. You use engine APIs to define the runtime functionality of your application, including graphics, physics, character behavior, and responses to user input. Scripting API reference provides complete and authoritative reference for all public Unity APIs. Mail provides additional context and guidance. Okay, cool. Unity supports scripting in the C# programming language. C#, pronounced C#, is managed object-oriented programming language, which is part of the .NET platform and runs in the cross-platform .NET runtime. Other .NET languages can be used with Unity if they have a compatible DLL. Refer to the managed plugins for the wait, can I do C++? A managed plugin. Coding the DLL. Fuck it. I'll just fucking use a public static and damn, dude. I haven't. Okay, so this is like, I guess C# is kind of Java adjacent. I haven't used the word static in so long. Public static int. What I need to also do is C++ to C#. Cheat sheet. Bool byte is unsigned car in there. Okay. W car. Okay, wait. Because I do have pointers. Okay, that's not that great of a. That's not that great of a cheat sheet. Not gonna lie. Developers cheat sheet for C# 9.0. So with C# 8. Sorry. All right, immutability. Property that symbols and programs can have. We are so used to the variable terminology that there seems to be no distinction from a symbol we declare to identify some value than the concept of a variable. This is because OOP is centered around the concept of imperative assignment, where any symbols presenting data can be mutated as we wish, perfectly matching the variable nomenclature. FP, on the other hand, is centered in the opposite concept of immutability. The universally known equal syntax has a different meaning, not assignment but binding. So whatever is on the left is not a variable anymore, but an invariable, if you like. What a bad term. But I prefer to use the term symbol in the place of variable. Immutability is evil. C# cannot define immutable types. Oh, did the YouTube thing... Oh, I'm buffering on all ends. Uh-oh. It looks like my stream on Twitch is up. Okay, weird buffer. Thanks, YouTube. Appreciate that. That was not necessary. I'm glad you did it there, though, surely. Is that a YouTube diff? I don't know. I don't know if it is or not. We should put YouTube on the bottom. And put you above. Yeah, that's better. Cool. Alright, let's go back to this. And it only brought a whole line. I'm gonna find the new fucking page. Two verbose for a cheat sheet. Here you go. C# quick reference cheat sheet that provides basic syntax and methods. class hello. Static void main string args. Wait, is that really C#? Holy shit, that is literally. We're probably not be using main though. Unity probably has like a main function in it that is its own main thing that we're running other stuff off of. Single line comments are the same. If else, same shit. I don't like this. I'm doing new lines. Car, string, int, bool. It looks mostly the same. Dot contains. I guess int long, float, double decimal, bool string. Okay. I might have that open later. Does C# use pointers? Primarily for manipulating value types such as int blah blah blah. In .NET, memory management for reference types is entirely handled by the garbage collector. Impossible to obtain their addresses, therefore unable to use pointers for manipulating reference types. So no pointers? How pointers scare C# programmers, because supposedly there aren't pointers in C#. However, on official website, pointers are referred to with regards to C#, creating strings out of pointers pointing to character arrays. This doesn't bother me so much because I started programming in C, but I always just under the impression that C# didn't have pointers, rather they weren't used in this case. Pointers exist, like others said, it's just very rare that you need to use them. It is much like Rust, pointers exist, raw pointers in Rust. You should avoid using them whenever possible. They're relegated to an unsafe context. The joke should be really that most C and C++ programmers aren't scared enough of pointers, except that isn't much of a joke. A huge amount of security issues are a direct consequence of fearless programmers using pointers incorrectly. That's very true. Like that Windows one, oh my god. Modern C++ does try to hide pointers behind abstractions and rules how to use them safely. It's never going to be as good as the language that was designed with a similar mindset from the start. This is C#'s current situation with nullability. Null reference exceptions. Their null static analysis is also a trap. It doesn't prevent nulls from being passed into a method, so it lures devs into thinking that they don't need to check a parameter if it's null before use. At least the new null argument checks are coming in C# 11. Okay, that was 3 years ago, so. They're not safe. Unsafe if you want to use pointers in C#. C#, do you pass by reference? They're passed to functions by value. Copy the variable is passed to the method. For reference, class types, a copy of the reference is passed to. So I wonder what I'm going to be using here. Because C++, you just go take it. You don't need to remake the value itself. But in Java, it was always by value. So it would remake, it would only send you would have to like recopy it in. Be like, okay, yeah, here it is. Public static void. I forgot what the fuck static meant in C#. C# static means relating the type itself rather than an instance of a type. You can access a static member using the type name reference instead of a reference or a value. GUID. New GUID, in addition to methods and variables, static. Okay, that didn't tell me anything. In short, static effectively means associated with a type instead of any one instance of the type. So there's one set of static variables for a type in an app domain, whether you have 0 instances or 1,000,000. You don't need an instance to access a static member variable. Okay. Right, okay, so static just means like, hey, this value is literally going to say static. I know it's like redundant, but essentially if, say like you're in a class, say you're in like some game object, right? And you're like, hey, I have another object here, and one of the values is static. So say the value of like jump height is static. That means that no matter what object it is, that value is always the same between whichever object this is. So if I have like 10 birds, for example, right, their max speed is the same for everyone, which, you know, obviously not true, but like in real life. But hey, you know what? We're not doing real life. We're fucking programmers here. Fuck real life. Am I right? No, I love real life. Real life is awesome. But yeah, that makes sense. So where read-only fields can be static or instance, related to the type or related to an instance of the type. Const values are always implicitly static. Okay. Alright, that's fine. Unity C#. Static. How often do you use static? When do you use static? So many people seem you never use anything static ever. Then sometimes these static methods being used in Unity tutorials. I understand that classes that derive from model behavior never have to be static. But when dealing with editor methods or method classes don't inherit from model behavior, I have a tendency to want to create static methods so I can access utility methods. Save, file stream path, blah, blah, blah. Do you want to do this? Creating utility classes that I can use enter in my scripts, but it confuses me when people say never use static methods anymore, ever. What's an alternative? Everyone's saying to never use static ever. That's ridiculous. I feel like that's very stupid. It's like when people say, hey, don't ever use tick. That's very, very wrong. You have to use it right. It's like with great power comes great responsibility with everything here. Of course, I'm speaking like this, but I'm not that smart. I'm just gonna say it. I just want to keep repeating that. So a static function makes perfect sense if, for example, it doesn't rely on the state of any particular object. Mathish functions, think lerp or sign, which are simple in-out functions where the only information that they use comes directly from the parameters being sent. It makes sense to be static if it has to do with the state of the system itself, which is why many file system accessing functions are static. Using a singleton pattern or something similar. Singleton pattern, by the way, is like, hey, you can only ever have one of these, ever. That obviously involves using static. Wow, I was on a roll here too. Now I'm stuttering. Using singletons in itself comes with its own data design caveats and should not be used carelessly. But if you're using one, use the static. The use of static is required. Otherwise, what's the point? I was literally coming into this thread to just now ironically post never. They offer any explanation. They don't know what static is, or the opinion is taken out of context. Static master should be stateless. If you require a state, then you're using static incorrectly. I scared this like singleton. What I meant stateless versus stateful is that a stateless method acts the same way regardless of the state of the program. A stateful method can act differently just because. Unity, Engine, MathF, and Math classes are full of static methods. If I call math sign X, it's like it'll act like sign regardless. You get component game object, not a static. Depends on the state of said game object. Do note though, if you could have a static version of this, often written as extension methods. This is often fine as well. But if, let's say, you have a global static get component that returned a component off some arbitrary game object in the scene, yeah, it's probably a bad design again. Again, singleton sort of skirts this, but singleton also has huge criticisms because of this. Where you start really getting into issues, though, is that some people use statics for really bad things. For instance, you have a player attack script and an enemy health script. Player attack wants to reduce the health of enemy health when some event occurs. Button press, trigger, enter something. Thing is, player attack doesn't have a reference to enemy health. So some people will put a static variable on enemy health called health. And then the player attack just says enemy health minus that. But why would you make it static? That makes no sense. Called health and then put enemy health dot health on enemy. Why would you put it on enemy health? That doesn't make any sense. Who would do that? Well, yes, this does reduce the health of enemy health. Now all enemy health is still the same health. You can't have two enemies now. Or rather, if you have two enemies, you kill one, the other dies. It's these sort of designs that you were talking about when they said never use statics, because rather than wanting to explain the complicated relationships of objects in the game, it's easier to say don't do it. They're just parent telling their kids to stay abstinence. You have some pretty good ideas. That's actually crazy. Holy shit. I think there are some just could be on static works. I want to keep coders from overusing it. Just take the time to understand. There's no reason not to use them when appropriate. Yeah, dude, I was the same way with tick. I feel like with tick, it's just such a like taboo thing. But like when I was reading it, I was looking through a bunch of stuff, and you know, it's always like, oh, no, don't do it. But I'm not gonna lie, tick probably one of the best things to use when it comes to like moving things. Other than that, I haven't found like a crate. Like it's you can use tick, trust me. Like in Unreal, just disable it when you're not using it, pretty much. Just don't have it always running, and you should be fine. And also don't, like, you know, it just depends on a lot of stuff, but you have to, like, you have to use it right. That's the only thing. Like, once you figure out how to use it right, and you're like, okay, I'm not, like, abusing it. Things, like, if you're using tech to spawn a bunch of things, that's really bad. That's obviously, no. That will make it not good at all. But if you're using it to just, like, hey, move this variable slowly, or move this thing very slowly towards this direction or something, that works perfectly fine. All right, Unity scripting environment. C#, Compiler DLL. Refer to manage plugins, right? Your own local environment, constantly rewriting code, your IDE. All right, we're just gonna use C#. How scripting works in Unity. C# scripts files with CS extension. Okay, CS. Let me check my VS Code. Do I have any CS files? No. Okay. C# scripts files with a CS file extension are assets in your project. I need more water. So I think what I'm going to do is in my game objects folder that I made earlier when I was complaining about the the menu thingy, what I'm gonna do is to make a CS file and be like, hey, extending this. C# scripts filed with a CS file extension are assets in your project. Stored in the assets folder and saved as a part of the asset database. Hold on. They're assets in your project. Any media or data that can be used in your game project. An asset may come from a file created outside of Unity. Okay. Assets folder of the asset database. I'm guessing that's just. You need to convert the data from the asset source file into a format like using the game or real-time application. It stores these converted files in the data system in the asset database. I'm guessing that's just like the little box, this thingy right here. Asset database. Is that music loud, by the way? I can't tell. Hello. Okay, it's like the same volume as me. Holy shit, my bad. Put it down a little bit. There you go. I think it's also coming through my mic. Oh well. C# scripts. I already read that. Okay. You can create template scripts that derive from common built-in Unity types. Do the scripting submenu of assets create menu. All right, so I want to make one of game object then. So I'll come back. Keep moving ahead. You can configure a default external script editor, which is the program Unity opens your script assets for editing. This will be one of the supported IDEs for Unity development, which we're using VS Code. Your custom types inherit from Unity Engine.object will be assignable to fields in the inspector window. Inheriting from model behavior also allows a script to be attached to a game object as a component to control the behavior of a game object in the scene. Okay. Inherit from object. Okay, one thing I'll give Unreal's documents. Hold on, wait, maybe this will have it. Base class of all built Unity objects can be defined in scripts by deriving a new class from types. Typically, scripts will use types derived from this class, material, and mesh, so that properties for those things. Okay, so I would do it on game object if I want to do a, what's it called? Added to a game object. Okay, so it looks like anything that's like one of these. Is this model behavior? It doesn't say. One thing I'll give about Unreal's like documentation is that they give you like the tree. The tree is really cool. All right. This is so you can create your own regular C# types and logic to use in your game as long as the code you use were compatible. You write is compatible with the active .NET profile. But your scripted types gain additional functionality in Unity when they inherit from a built-in Unity type. We will definitely be using that. Therefore, the object will be assigned to the fields. Right. Inheriting from model behavior allows a script to be attached to a game object as a component to control the behavior of the game object in the scene. Fundamental Unity types. Is that what I just opened? Okay, yeah. We'll come back to that. For more information on viewing scripts and editing script components in the inspector, inspecting scripts. All right, we're coming to that. Compilation and code reload. Compilation transforms the C# code you wrote into code that runs on the given target platform. Some aspects of compilation are under your control and others aren't. By organizing your scripts into assemblies, you can reduce the unnecessary recompilation and manage your dependencies effectively. What the hell? With conditional compilation, you can selectively include or exclude sections of your code from compilation? Why would I want to do that? What the hell? What did this open? Oh, it's this one. Organizing scripts into assemblies. Assemblies are individual units of compiled code that group types and resources are together. Organizing scripts into assemblies has important advantages, especially as your code base grows. Assemblies help you think clearly about the architecture of your code, about managing your dependencies. By exercising fine-grained control over references, you can reduce unnecessary recompilation time, make your code easier to debug. Yo, we got the bots back in here. Soundless Fowl. Best viewers on streamboo.com. Disgusting. Get out of here, freak. I won't ban you because I need the chats, alright? So, respect that, douchebag. Understand the fundamentals of how assemblies work in Unity and why using them to organize your scripts is beneficial. Unity provides two special asset types, assembly definition and assembly references. Help organize your scripts into assemblies. An assembly is a C# code library that contains the compiled classes and structs that are defined by your scripts, which also define references to other assemblies. A predefined assembly called assembly C# WDLL. Unity also creates a few smaller specialized predefined assemblies. This arrangement works acceptably for small projects, but small drawback as you add more code to your project. Every time you change one script, Unity has to recompile all other scripts, increasing overall compilation time for iterative code changes. Any script can directly access types defined in any other script, which can make it more difficult to refactor and improve your code. All scripts are compiled for all platforms. By defining assemblies, you can organize your code and promote modularity and reusability. Scripts and assemblies you define are no longer added to the default assemblies. You can only access scripts in your other custom assemblies. This is actually pretty cool. It shows how you might split up code in your project into multiple assemblies. Main references stuff and not the way other way around. And change the code in main cannot affect your code in stub. Similarly, because library doesn't depend on any other assemblies, you more easily reuse code in library. So we probably won't need to do this, but this is actually really nice to know. Write your project in assemblies, create a folder for each desired assembly, and move the scripts that should belong to each assembly to the relevant folder. Oh. Gotta find a good stretch to do. Then create assembly definition assets to specify the assembly properties. Unity normally compiles any scripts and folders named editor. Predefine that as assembly no matter where those scripts are located. If you create an assembly definition asset and a folder that has an editor folder underneath it, Unity no longer posts editor scripts into the predefined editor assembly. Instead, they go to the new assembly created by your assembly definition, where they not belong. Manage editor. Okay, so we are not going to need to use this for now, but it's good to know. Good to know. Good to know. All right, we're on creating scripts now. This is the important one that we're trying to look for. So scripts allow you to customize and extend the capabilities of your application with C# code. With scripts that derive from Unity's built-in model behavior class, you can create your own components to control the behavior of game objects. With scripts that derive from scriptable object, large amount of data efficiently in your application. You can start with an empty C# script to develop your own non-Unity classes. Unlike most other classes, scripts are usually created with Unity directly. To create a script, we may go to create scripting. Create menu plus sign in the project window toolbar. Go to scripting. Select the type of script you want to make. This creates a new script in whichever folder you create. Script's file name for editing, prompting, and changing the name. Yeah, what's the naming convention for Unity? Class name and spaces. Choose names for your file scripts and classes declared inside them carefully. File name and organize your classes under namespace and ensure the compiler can identify classes without errors. Script file names. The file name you enter on creation of the script will be used for the name of the class defined inside of it. Match the name of the class defined in it. True. Mono behavior. Scriptable object. Unity can resolve a class type defined in your script even if file name doesn't match, but there are some limitations. We're just going to keep it the same. Naming conflicts arise when multiple classes with the same name are declared in different parts of your project. With a scale of the project and a number of contributors. For example, one developer might write code to control the main player character for the enemy. If both developers choose to call their class controller, the compiler won't be able to determine which class usages of controller in the code refer to. Organize your classes under namespaces. A namespace is a collection of classes, and the namespace prefixed to a class name provides a complete, unambiguous way to refer to the class. Refer to Microsoft documentation on namespaces. For members of the thing called namespace, or enemy. Okay. Namespace, public class, do this. You can reference these classes unambiguously in code by generating their complete name. Complete name of the namespace is the namespace plus the class name, and in this case, enemy.controller1, enemy.controller2, respectively. You can add the namespace declaration around existing class declarations, so you don't need to change the names of all the classes individually. You can add namespace declarations around classes wherever they occur, even if those classes are different source files. You can avoid having to type the namespace prefix by adding a using directive as enemy controller1 and controller2 respectively. If the script needs to refer to classes with the same name using a different namespace player, then you must specify the namespace prefixes. Okay, so damn, I have to kind of like remember what the fuck to do in Java. This is feeling real Java-like. Damn, I've been on C++ for so long too. All right, we just went to naming scripts. Let's go to inspecting scripts. When you select a script asset in the project window, an inspector displays some basic information, including the name of the assembly it belongs to. Although it displays the content of the script, you can't edit the contents in the inspector window. Yeah, that makes sense. Open an execution order. Open performs the same function as double-clicking the script in project window. You can configure which external entity. Okay. The execution order button opens the script execution order of the project window, where you can configure the order in which Unity executes your scripts. Script components in the inspector window. Any model behavior script can be used as a component. You can attach the script to game objects. You can edit the script's properties in the thing. Unity engine, that's probably one I'm going to need to use. Example code declares public field called my name. Hold on, let me also do this. Alright, this is their actual website too, so big dubs. Dub. Where did here it is, okay. Is this thing okay? Why is it not loading? Is my internet just fucking up right now? There you go. Thank God. You can't define variables with names, with the spaces in the name. The space character to just separate identifiers. Yeah, that's fine. Well, no naming command. Okay, but which one does... What do you guys use? I use Pascal case. It's my favorite. Hungarian notation. What the hell? Variable? Oh, wow. Okay, that's kind of crazy. Shit. Kebab case. That's funny. Snake case. Kebab case is crazy. I'm a Pascal user. Not commonly used in Unity development. Yeah. Examples to avoid. D. Hey, what's wrong with D, man? Come on. Last time in days. Get movement speed. Okay, yeah, that sounds like a function. Fields and variables. Consider these rules for your variables and fields. Okay, I don't care about that. Actually, I should care about that. Okay. Nouns for variable names. Variable names should be clear and descriptive because remember that specific thing or state. Prefix booleans with a verb is... I like putting a B. That's the Unreal way to do it. Is, has. Alright, I'm just going to use that. Use meaningful names. Don't abbreviate unless it's math. Your variable names will reveal their intent. That are easy to pronounce and search for. They're fine. Don't abbreviate in other situations. Clarity is more important. That is very true. Going back to look at old code. Oh. Okay, so here you go. Short junk names, yeah. Use Pascal cases for public fields. Use camel case for private fields. Really? Alternative public fields use properties with the public getter. Avoid too many prefixes or special encoding. You can prefix private member variables with an underscore. Differentiate them from local variables. Use this keyword to distinguish between member variables and local variables in context. Yep. Some style guides use prefixes for private members, M, constants, K, or static, K for constant. That's crazy. And then can reveal even more about the variable at a glance. Many developers eschew these and rely on the editor instead. However, not all IDEs support highlighting and color coding. Yeah. Specify or omit access level modifiers consistently. If you leave off the access modifier, we'll assume that it's private. Okay. In Unreal, that it assumes that it's public. So that's a thing to know. Works well, but consistent how you met the default. Remember that you need to use protected if you want to use this in the subclass later. Yep. Okay, so you declare the variables at the top, and then your things are underneath. Okay. Public void, inflict damage. Float bool is special damage. Okay, look at these float here at least. That's pretty cool. I remember back in the day it was like double for Java at least. Didn't really use float too much. Total damage. Public. Private underscore. Really? Okay, I'll have to remember that. Enums are special value types defined by a set of constants. Constants are integers counting up from 0. Alright, I'm gonna actually write this down real quick. Alright, Unity notes. Coding conventions. By the way, I use the note-taking app Obsidian. Pretty dope, actually. My friend put me on it. I was like, okay. I spent like 2 hours adding a bunch of add-ons to make it how I want it. Actually crazy. Public variables. Pascal case. Each starts cap. Each word has cap. I'll be like damage multiplier.
Private variables start with an underscore and our camel case. Is dead. Fuck. Is dead. Cool. Functions are our Pascal case, and parameters are all our camel case. Okay. Enums are special value type. I kind of hate it when they start with underscore, but we'll get used to it. It's no worries. Enums are special value types defined by a set of named constants. By default, constants are integers, counting up from 0. Use Pascal case for enums and values. You can place public enums outside of a class to make them global. Oh, okay. Use a singular noun for the enum name. Bitwise enums are marked with system flags attribute are the exception to this rule. You typically pluralize these as they represent more than one type. Okay. Enums use singular nouns. Weapon type. Enums are Pascal case. And outside of a class makes it global. So I wonder how that works with the actual thing. The engine itself. So it's... That's not what I want to do. That's not what I want to do. Public enum weapon type. Knife, gun, rocket, launcher. Can it equals after and set the number. Otherwise, it will start as 0, 1, 2, 3, respectively.
What is this? Wow. Melee and special. 1 and 4. Wait, does it just add it? I've never seen these. A bitwise enum is plural. Attack modes. I'm never going to use a bitwise enum. I don't think so. Follow these standard rules when naming your classes or interfaces. Pascal case nouns for class names. It'll keep your classes organized. If you have a model behavior in a file, the source file name must match. You might have other internal classes in the file, but only one model behavior should exist per file. What? Oh, yeah, that's extending. Prefix interfaces with capital I. Yep, that's usual. All right, so you can have interfaces. Let's go. Public interface I killable. I'll write that down. Interfaces. Ooh. What's it at? Okay, YouTube should be saved. Let me go to the settings folder real quick. Stream. Twitch. Fans.
So let's see if that fixed it. YouTube's still getting shit bitrate, but hopefully it's at 1080p now, so it's not like trying to kill itself actively. All right, I see Twitch up. So Twitch up. Twitch has red bitrate though. Oh. Nope, it does not like that. Unstable. Why is it poor? 10-second unstable event. Holy shit. 2 unstable events. Wow. Live, no delay. I can't tell if it's okay. It's stable. It says it's stable here. So it's just lying to me here. Let me give it a refresh on the dashboard real quick. All right, we're back to excellent here. Excellent. All right, my stuff looks a little bit better. I'm not like lagging as hard. I move my hand around. All right, Twitch is chilling. I'm gonna close that. Now let's see YouTube real quick. I'll move that right there. I'll go ahead and refresh this. I think I was streaming at like 1920 by 1080 the entire time. All right, we are so back. I think we're literally so back. Your channel. There you go. Everything looks a lot better. I'm streaming at 1080p instead. Holy shit. Dude, no wonder it was trying to kill itself on YouTube. Okay. I think we should be good now. 11 views. What's up, guys? 11 people came in and they're like, nah. That's funny. Alright. Let's go back to this. So I should have the guy by now. Alright, art, characters. There you go. Low poly. Low poly. Demo free. Editor. I want this guy. Humans. Prefab. So that is the prefab itself. Ooh. Yep, look at that armature. Dang, dude. Underwear. That's crazy. How do I get out of the actual prefab view? I don't want to close the tab. I just want to go back. There it is. Okay, sick. It's just that button. Meshes human. Armor mesh. I don't care about the free human poly low. Demo free. Lighting data. Alright, so those are the animations of it. Meshes. Okay, well, you're not helpful. Show and Explorer. Damn, I'm not allowed to like just view it here. Is this the preview? Is this all the preview I'm getting? Oh, that's not too bad. Okay, cool. You can't really zoom into it. It sucks. But you know what? I used to see it. So that's one thing. McT space. Oh yeah. Armor mesh. Get out of here. Alright, so that's his armor and stuff. I don't really care about the armor. I just want his materials on. Why are they all pink? Is that how it's supposed to be? Albedo. Why are they all showing as pink? So I don't know how to open them. Where's the material editor? Show and Explorer. Nope. Animations, combat. Whoa. Nah, it can't be viewed. Okay. Can I see it here? Demo low poly character. Okay, let's go to the prefabs. Where to go?
With the animation, then the characters. And then what is this? It's a .unity file. Yeah, don't save, I don't care. Oh, where is he? He's all pink. I don't think it's supposed to happen that way. Controller. Why does it just click play? What do they got on him? They have the animator. Oh, okay. Oh, he's got the idle animation. Nice. Always animate. Apply room. Oh, you got room motion here too. Nice. Coolio. That'll help some stuff. Demo free. Editor. Material tiling. Animator controller. Go to original value. Nope, that's not what I wanted to do. Where is the controller? Also, how do we even do this? This is crazy. Why is the character so untextured? I don't understand. Damn, man. This is a little annoying. Just a little bit. There you go. What's this? Material tiling. Nice, okay. I guess it is what it is. I'll have to learn it. Meshes. Prefabs. Here you go. So this has the animator and the transform. Let's go back. Back to the original scene. Yeah, we're gonna use the sample scene. And we're gonna go to art, characters, prefab humans. And click play. And he should be animating here. Oh crap, is there a way to get out of the camera? I'm gonna change the rotation real quick. Oh, it's not sliding? Okay, fine. What the? That's the yaw, isn't it? Nope. I guess not. That's the roll. Oh shit. I forgot. They have it. So Z is up in Unreal. So it's like it's right hand rule. X, Y, Z. Some shit like that. We don't even have the gizmo, so whoopsies. I guess Y is up. Give me 20. Negative 20. Negative 50. Where is the camera? We're at... Hold on. Where is this guy? Where is your position? No, go to 0, 0, 0, buddy. Where the fuck did he go? Take me to him. Perfect. Oh, crap. Play. Nice. Okay. Alright, so he's just gonna be pink guy for now. That'll be okay. I'll learn how to adjust this stuff later. For now, we want to try to make our character guy, actually. Don't destroy on load. So, these are accessories. These have accessories on? Underwear. I can't even tell. That's crazy. That's actually crazy. You literally can't even tell it's on. Albedo. I can't even change the color of it. It's so weird. Why is it pink? That's what we need to figure out. I'm sure these shaders aren't just pink. If I knew how to edit them, I could open it and see what errors they have. But it's not just like that here. seems. Albedo. Oh, here you go. Hold on. This is not what I was looking for. Standard shader. Nope. Emission. Oh. Let me see. Let's watch the rest of this first, real quick. Let's see it.
It's you in the middle. Go ahead and take your main camera on the left there. Here you've just made the 3D object and capsule, and this is going to be you. I'm just going to call it player, so you can see that's you in the middle. Go ahead and take your main camera on the left there. Go ahead and drag it into that player file there, so you should see that.
Sorry.
Click on your main camera on the left and go into the inspector panel over on the left there. Go ahead and drag it into that player file there, so you should see that this is in cam 2. I'm just going to call it player, so you can see that's you in the middle. Go ahead and take your main camera on the left there. Go ahead and drag it into that player file there, so you should see that this is a folder with the 2 objects inside.
Okay.
Click on your main camera on the left and go to the inspector panel. If you don't see that, go Window, General, and Inspector. Reset the camera to 000. This should get it inside of your player, and then drag it to the top. This.
Damn. Okay. Let's do this. This has the armature, the mesh, and everything on it already. So I'm gonna consider. I kind of need to learn how to do. Okay. So. Say we have the mesh itself, and it has this guy in it. I'm gonna go over here and do it over here. Oh wow! Oh, actually textured now. Kind of. Not pink at least. Clone. Oh, it has an armature on it already? What the fuck? Where's the camera? Come here. Doink. I can't even see where it is, low-key. I'm just gonna assume that it's right there. And... Oh my god, it was literally not played. Wow, okay. Why am I... Dude, I cannot tell sometimes that when I'm in play. That's crazy. Where is the icon for? How does his have the icon on it? It's not static. Main camera, ignore recast. Base, perspective, yeah, that's fine. Audio listener. I don't know about that. Let's play the music one more time. Do 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 do. Connectivity issues. Oh yeah. Oh yeah. All right. Right there. So it's like facing that. I think that's facing that. All right. I can't tell what the forward vector is on this camera. Damn it. Dang, I wish you could like. Oh, it's so useful to do that. Oh. Hold on. There it is. Damn. It's like, where the fuck is that shit? Oh, it's pressing pause. How you get out of it? Alright, so the armature's in there, but the animation isn't. Okay. How did you do it here? It has an animator on it. This has no controller on it. Is the armature here? Let's see. I want to do it from like scratch almost, even. Well, maybe it's just because it comes with it, so it's like, yeah, hey. You know? FBX has the armature on it. So what's this controller? Low poly human animator. I want to go to that file. Where is that? What does this do?
Runtime animator. Low poly runtime animator. Animation. Combat. Punch gathering. Free. No, I don't want the prefab. Where actually is that? Is there a way to search in here? Oh, it is. Nice. Click assets. Low poly. Where is this? It's in characters. Low poly. Demo free. Here it is. Okay, so what's that? The PP profile. Monoscript can be loaded. Assign a valid script. By the way, how do I enable the debugger? The PP profile. What is that? Okay, whatever. Lighting data. Demo. That's the scene. Alright, here you go. Here is the tree. Wait, okay, let me find out how to open the material. Unity. How to open material editor. That's not what I was looking for. Ah, fuck. My throat. .net. How to create material. Oh, I have to do this. Create animation. No. Time, dude, it's getting dark already. This is crazy. Terrain, C#, shader graph, shader, ray tracing shader, custom render texture, search, scripting, scene, rendering, lens flare, audio mixer, a material. There it is. Yeah, new material. But how do I... Was there not a material graph editor? I thought there was. No, that's not what I want to use. Like, Unreal has their material editor, and I thought I saw something like this. Any state. On entry, go to idle. Exit. Substate machine, clear state. How do I make an arrow? Make transition. There it is. Nice. Okay. That shouldn't be too bad, actually. Well, can we do it based on anything? Conditions. Parameter does not exist in controller. Okay. Now, how would I make parameters? Unity material editor, like Unreal. A Unity shader. Okay, so I don't want a material. I would want a shader. Unlit shader. Compute shader. Shader variant collection. Standard surface shader. Oh, wow. Okay, so you have to actually code it. Goddamn. Unreal Material is a Unity shader. Which allows the user to create, okay. Texture maps, color values, and other properties. Okay, but how do I get to it? Node-based graphical interface. Where is it? On Unity shader graph. That's what I want. Yerp. Let's see this. Let's see if there's anything here actually. Boom, 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 boom. Boom, 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 boom. We're popping on it. We're drumping on it. SRP packages are part of the core. Get started. URP. Unity manual. Okay. URP. Public roadmap. Getting started URP. Anti-aliasing. Shaders. Pixel on the screen. Compute shaders perform calculations on the GPU. Bada bing, bada boom. We're doing it to them. Write custom shaders. Shader graph. Here you go. Shader graph is a tool that enables you to build shaders visually. Instead of having to code, you create nodes. Shader graph gives instant feedback and reflects changes, similar for users who are new to shader creation. What? It doesn't have any information on it. Writing shaders in code. Where is the shader graph? How do you get to it? Let me delete this. So what is this again? It's a dot controller. Create animation controller. Okay. That's all you need from that. And then I could be like, hey, I'll override this. And get a reference to maybe the game object. I have no clue. You know what we're gonna do? We're gonna see if we can just follow a tutorial maybe.
That might make things a lot easier.
This is for first person. If you want third person, you can go ahead and just drag that camera wherever you want. So I'm just going to drag it a little far away and you can see a third person view. But for this, I'm just going to do a first person. Right click, go 3D object and create plane, and again set this to 0, 0, 0. Click Y and then grab that square in the middle and drag it out, and this is going to be the plane that you're actually going to be walking on. Now what I'm doing here is I'm just creating some cubes just for reference so you can see that I'm actually moving, because without them it's a little bit difficult to see. It's just a plain background if you're actually walking around. Go ahead and right click on the bottom here, go create and make a new folder, and this is just for a good habit of organization to keep everything nice and organized. Right click again, go create C# script, and then go player movement and double click on that player movement script that you've just created there. Now go ahead and paste this text in. You want a detailed explanation of what all this does, just let me know in the
Jesus.
comments and I'll be sure to make one. And also make sure that right beside public class, that player movement thing there, matches the name of the script that we called it, so it's going to be player movement here. I'm now going to click out of there and let it save. I'm going to click on my player file, not the actual player, but the folder itself. Drag the player movement into there, so you can see it's now created a character controller and a player movement script. Now take the main camera, drag it inside of there, and now you can change these to whatever you want. I just had them set to some stuff, but I like to change it a little bit. You got your walk speed, your run speed, all of that. Start your game, and you can see that you are successfully moving around perfectly with no issues. Space to jump, WASD to move, left shift to sprint, and R to crouch. Of course, you can change these controls as well inside of the player script if you want. If you have any questions, let me know in the comments.
Unity 3D tutorial. Open world survival game. Beginner tutorials. Basics E1. Unity for beginners.
Hi, my name's Mark.
Alright, Game Maker's Toolkit. We're gonna do it to him. Let's do this.
Using software like Unity. Unity is the powerful game engine behind titles like Cuphead, Neon White, Tunic, Outer Wilds, Hearthstone, Firewatch, and even the Pokemon Diamond remake. But I've always found that lengthy, multi-part, meandering tutorials just put me to sleep. I can't learn by watching someone else. I have to get hands-on and figure things out for myself.
That's true.
And so last year, I developed
In
a
fact,
solution that actually works.
If he's gonna
3 steps.
if he's gonna link me a thingy, I want to be sad.
Technique where you, 1, just learn the absolute basics of Unity, then 2, cement those lessons with simple exercises, and then 3, figure out the rest as you go along. And it totally worked. In the space of about a year, I went from ripping off iPhone games to working on my very own puzzle platformer about magnets. And I released an interactive video essay that's had over 100,000 players. But wait, I hear you say, how do you do step 1? How do you learn the basics when the software is so complicated to figure out? Well, for me, it was about writing down a list of things I would need to know regardless of what game I was going to make. Things like how to make a character appear and move them around the screen, how to make stuff spawn in and then delete it again later, how to have collisions and game over and animations and sound effects. Then I learned all that by hunting through lengthy tutorials, reading the Unity docs, googling esoteric words, and doing a lot of trial and error. And so the whole point of this video is to save you that hassle. This video is the tutorial I wish I had when I was learning Unity. So in the next 40 minutes, we're going to use the engine to make Flappy Bird. Not because we want to make Flappy Bird, but because in order to remake this addictive iPhone game, we'll need to learn basically everything I just listed, from spawning objects to getting game overs. This tutorial will cover every step of the way, from downloading Unity to understanding the UI, to writing your very first line of programming code, to building a game that you can share with your friends. And then, when the tutorial is over, I'll share some concrete next steps that you can take in order to continue learning the rest by yourself. Sound?
I'm also gonna look up something else here. Unity. Sorry. The Unity tutorial. Ugh. No. Oh, here you go. I don't want the convert. No. Oh, it's me. Look at that. I wonder if it's because it's my stream. So they're like, hey, give it to him. Learning Unity be like. We're watching it through the preview. Okay. Dude, I don't know why I can't find like. This looks interesting.
Hi, this is developer update 6 for A Knight's Gambit, a Stafford University final year
Oh.
project. Following my last update in the Digital Academy forum, a basic board
Okay,
system has
then.
been implemented. The hardest part of this update
Huh.
was getting the card mechanics to behave properly, as the on-hold is simple at the minute.
Holy shit. Fucking
It'll stay
blueprints.
there. Ideas is that if you drag it outside of the card area, it'll stay there. Ideally, I want it to be returning to the player's hand.
Alright, I don't need that. Unreal. Dude, I need Unreal to Unity. Jesus. 6 hours. Holy shit. Okay, who made this? No. Full tutorial. I think I was gonna watch this one a while ago. Dude, they don't have any. Why is it all Unity Unreal? This is so ass. 7 hours. Holy shnikey. Well, you should not use Godot. Jesus. Fixed particles disappearing. No, okay. Well, I'll stick with the other stuff. I'm gonna watch Game Maker's Toolkit.
You will learn how to make a complete 2D plan.
Okay. We're going back
Okay,
here.
let's start by getting Unity from the website. Download and install.
Yeah, I already got that. No worries.
In step 1, we're going to become familiar with the default Unity user interface, and as
Yeah.
we explore the different panels, we'll make the bird appear on screen. Right, so this is the default screen layout for Unity, and it's split into 4 panels.
Okay.
First of all, down here is the project panel. This will contain everything that is in our game, like sprites, sound effects, scripts, tiles, fonts, and so on. Some of this stuff will be made in Unity as we go along, but we can also just drag and drop files from elsewhere on our computer. Like, I've made some sprites for the bird and the pipe in Photoshop, and I'm going to import them into my project, like so. I'd recommend you make your own, that's also fun. If you have zero artistic ability, then check the description for these assets. The next
Nice.
panel is the hierarchy. This contains all of the stuff that's in the current scene, which in most games will be a level. We're going to start by making the bird, so right-click and choose Create Empty. This has made an empty game object. So, what's that? Well, a game object is essentially an invisible container. It has a position in space, a rotation, and a scale. Then you can fill that container with components to add extra features. For example, if we add a sprite renderer component, we can slap the bird image onto the game object. Absolutely everything in our level will be a game object with components. The bird, the pipes, even the user interface, and the camera. All of this magic happens in the third panel, the inspector, which is for messing with game objects. So once we've selected our new empty game object, we can put a name in the top field, let's call it bird, and we can see and change the game object's position, rotation, and scale under transform. We can now press add component, pick rendering, and pick sprite renderer. To make this work, we need to fill in the sprite field, so just drag the bird image from the project panel into the field, and voila, we have graphics. That will, of course, show up in the fourth and final panel, the scene view. Here we can see what's in our current scene, and if you want, you can use these tools to move stuff around, scale it, and so on. This section has an extra tab for Game View, which shows us what the game will look like from the main camera when it's running. Also, from this drop-down, we can set a resolution or aspect ratio to get a better idea of what it will look like when
Nice.
So I'm going to choose 1920 by 1080. Oof, the bird takes up way too much space. We could scale it down, but let's actually just zoom out the camera. Like I said before, the camera itself is a game object in the hierarchy, and it has a camera component with stats we can mess with. By changing the size, we can zoom out. I'm also going to change the background color. Lovely. We can now press the play button up here to start the world's most boring game. Okay, let's make it a bit more exciting. A quick recap. Unity has 4 panels by default. Project holds all the stuff in our game. Hierarchy lists all the game objects in the current level. Inspector lets us see and change those game objects, and we can see the level in the scene view. And a game object is an invisible container that we can fill with components like the sprite renderer. In step 2, we're going to use more components to make the bird into a physics object that is affected by gravity.
Okay. Programming code. Let's go. Okay. Give me a sec, guys. Let's see this. Yo, give me 1 second, boys. Let me go ahead and do this. I'm going to be right back. 1 minute. All right, we're back, boys. Let's go back to this.
And then we're going to write some program code to make the bird fly up when we press the spacebar. So let's add another component to our bird, a rigid body 2D. This turns our bird into a physics object with gravity. So when we hit play, the bird drops and falls off the screen. Cool. We'll also want this bird to be able to interact with other objects. So let's add a collider, a circle collider 2D. Back in the scene view, we can see the collider as a green outline. It's a bit off center for me, so I'll use the offset to move it. And a little game design trick. If we make the collider a bit smaller than the image, it will let the player get through the pipes, even if they just touch the edge. It gives the game a bit of leniency and makes it feel more fair. The final thing to add right now, a script. This essentially lets us make our own custom component, but we'll have to write it ourselves using programming code. Choose New Script from the components list and call it Bird Script. Once it's loaded, double-click the script field to open it up. This will open the file in Visual Studio, which we installed earlier. So, welcome to programming. It's not too scary, promise, we'll take it slow. We're writing in C#, that's the programming language, and the only thing to worry about right now is these two chunks here, start and update. Start is for any code that will run as soon as the script is enabled, and it runs precisely once. Update runs constantly while the script is enabled, and it will fire off every line of code, every single frame, over and over and over again. So the main thing we're going to be doing with code right now is, well, if we go back to Unity, see these numbers and text fields in the components and how we can change them in the Unity editor? We're just going to write code to change these stats while the game is running. Just as a dumb example, and we'll delete this in a second, in start we can type game object, that refers to this bit up here, and then a dot. You'll see a list appear, and many of the items refer to stuff back in the inspector, like is static, tag, layer, and name. So let's pick name, then write an equal sign, and in quotes, layer and name. So let's pick name, then write an equal sign, and in quotes, give our bird a name. Finally, we must always use a semicolon to mark the end of a command. And we must always save the script before we go back to Unity. Now, when we run the game, the name of the game object has been changed. Nice. Okay, delete that code, that was just for saves, but it shows us how we can use code to talk to the game. We can write a command by choosing someone to talk to, in this case, the game object, and then a topic of conversation, its name, and then a command. Change it to Bob Burlington. We'll be doing this a lot. So what we actually want to do is, in the rigid body 2Ds component, under info, we'll see a grayed out field for velocity, and we want to write some code to add upward velocity to the bird to make it fly into the air. The problem is, initially, the script can only talk to the game object's cockpit and the transform. Right now, script is completely unaware of the other components, so we need to sort that out first. We need to make a special slot on this script for a rigid body 2D, so we can then talk to it and send it commands. This is called a reference. We're going to create the reference up here between the class name and the start function. We're going to write public rigid body 2D my rigid body. So
Okay.
we now have a slot to store a rigid body 2D.
Okay,
We have a
that's
name
not
that
too
we can
bad.
refer to make sure we're talking about this
Dude, he explained it in fucking like 11 minutes faster than I fucking read it off the documentation. That's crazy.
specific rigid body 2D. And because we made it public, it means we can access the slot from outside the script. So if we save and go back to Unity, we'll see that the script component now has a field for a rigid body 2D. We can drag the component into that slot and voila, we have established a line of communication between the script and the rigid body. Okay, back in
Ugh, that's so stupid. I feel like you should just be able to make a game object. Be like, hey, this game object has rigid body 2D here, da 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 here, da 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 here, and then when you go into drag it in, you can be like, hey, okay, fill it out, and be able to access it from there.
Studio. In update, we can type my rigid body, then dot. And now look at all the things we can talk about. Angular drag, gravity scale, mass, these are all properties on the component. What we want is velocity. We want to set this to a new number. So just like before with the name, we'll write and equals. Now what we're actually writing here is a vector, which is two numbers to represent a position in 2D space. And in this case, it's used to represent a direction for the bird to travel. We want the bird to go straight up, so 0, 1 would be a good one. I'm going to use vector2.up, which is a built-in shorthand for 0, 1. And to give it a bit more power, I'm going to multiply that vector by a number, say 10, which should send the bird flying up in the sky. Now, like I said before, any code in update can run over and over again every frame. So if we save the script and hit play in Unity, off goes our bird. Bye. That's not what we want. We want this to only happen when the player hits the spacebar.
Bye.
It's time to use the most fundamental bit of programming code, the if statement. An if statement is like a gate. You can surround some code.
Okay. So I will need to look up how to use the controller. The animation controller. Okay. Okay, let's keep going with
In
this.
every frame, that code will be completely ignored, unless the game meets some specific conditions that are written on the gate, in which case the gate is open and the code is read and executed. So we want to say, if the player hits the spacebar, then add upward velocity. To do this, we can write if, and then in brackets, we can write the condition. This time we're not talking to a component, we're talking to Unity itself, specifically its input system. So we'll write input dot. Then we can pick get
Yes, that's
key
an
and in brackets,
Unity
keyboard
engine.
dot space. This asks Unity if the space
So input.getKeyDown is something that comes from using Unity Engine. It comes from that package itself, I believe. Okay. Bird script. Really called it. Okay.
bar has been pressed on this frame, and then we'll finish with equals equals true. A quick note on equal signs: we use 1 to make the thing on the left be the same as the thing on the right, and we use 2 if we're just checking if the thing on the left is the same as the thing on the right. Anyway, so this code says if the spacebar has just been pressed, then, and then we'll use curly brackets. These are the fence in our analogy, and put the flat code in here. So now in update, every frame the game will go to the gate and be asked, hey, has the spacebar just been pressed? If yes, the code will fire and the bird will flap. If not, it will skip the code in the curly brackets and try again next frame. So save the script and go back to Unity. We can now hit play.
Is that really
and
how you do
ta-da, the bird
inputs?
goes up when we
I guess
press
that makes
space.
sense.
We have now created a character and made it react to input. This is a video game. Hooray! However, it feels like trash. The flap isn't right and it doesn't feel like the original iPhone game. So we could change this number, save, open Unity, run the game, not quite right, stop, change the number, save, but that's slow and dumb. Let's do something smarter. First, we're going to make a variable. Let's go back to the
Public.
top of the script, and under our reference to the rigid body, let's make a public float called flat strength. A float is a floating point number, basically a number that can have a decimal place. And then back in our update code, we'll multiply the vector2.up by flat strength instead of 10. Now, back in Unity, you'll see that the script component has a new field, flat strength, and we can change that whenever we want to make the game feel different. We can even change it during the game, but note that anything you change while the game is running won't save when you press stop. This means you can play with values to your heart's content without worrying about screwing up the game. So if we mess with the flat strength and also the gravity scale on the rigid body, we'll hopefully get something that feels good. And changing numbers back and forth. Honey, that's game design. We can use code to change the properties
Honey,
of the
that's
computer
game design.
while the game is running. A script cannot talk to
Does he ever talk about logic and UI came over? Damn.
the other components of the
Okay.
game object by default. You have to make a line of communication by storing a reference to that specific component. We create the reference in code and then fill it in Unity by dragging and dropping. Code in start runs once when the script comes into existence. Code in update runs continuously every single frame. But we can use if statements to skip some code unless a condition is met. And we can use public variables to change certain values in Unity's sector even while the game is running. Okay, so the secret of Flappy Bird is that while it looks like a bird is flapping along for a world of pipes, it's actually not. the bird stays completely still, and it's the pipes that move across the screen. So in step 3, we're going to make pipes spawn into the world, move across the screen, and then delete themselves. We'll start by making the object we want to spawn. This will be 2 pipes which move across the screen from left to right. Let's make another game object called pipe. Put it exactly on the bird for now to get the sizing right. And then we'll make another object within this one called top pipe. This is a child of the first game object's parent. This way we can nest multiple game objects and move all of them at once. This will be 2 pipes into the world, move across the screen, and then delete themselves.
I should have known that
We'll
about
start by making the
what's it
object
called?
we want to spawn. This will be 2 pipes which move across the screen from left to right. Let's make another game object called pipe. Put
Pipe.
it exactly on the bird for now to get the sizing right. And then we'll make another object within this one called top pipe. This is a child of the first game object's parent. This way we can nest multiple game objects and move all of them at once just by moving the parent. So let's repeat what we did for the bird. Add a sprite renderer for the pipe image. And add a collider, a box collider 2D this time. We don't need a rigid body because it's not going to be affected by physics. We can then move it up above the bird, but keep the X position as 0. Finally, we can duplicate this whole top pipe object,
I
call
see.
it bottom pipe, and flip it upside down by changing the Y scale to -1. Then move it down below the bird. As you can see, if we mess with the pipe parent game object, both pipes move, scale, and rotate along with it, with the parent as the pivot point. So let's add a script to this parent's object to make it move across the screen. We'll start by creating a variable for move speed. If we give it a number here, it will fill this as the default value.
Probably wanna
in
make that one
Unity, but
static.
You can always change it there later. Then we'll write code to move the object in update.
Why you would want to make it static is because then all of them have that same variable. So
Now,
yeah.
it would be lovely if we could just type transform.position.x and change this number directly, but no, boo, you have to change the entire vector in one go. Oh, and this time we're going to have to use vector 3 instead of vector 2 because the transform has 3 numbers. Even though we're making our game in 2D, Unity is still fundamentally a 3D engine, and so it's keeping track of the object's depth with the Z value. So, here's what we'll do. We'll take the current transform.position and then equals. We want to add to its current position, so write transform.position again, and then plus. And finally, in brackets, we'll do vector3.left times move speed. Back in Unity, press play, and woof, that's left times move,
It was vector 3
and
dot
then
left.
plus. And finally, in brackets, we'll do vector3.left.
This is where we go here. Unity vector 3 API. And we go over here. Left is -100. Nice. So he's adding
left
-100
times move speed.
times move speed. Just
Back in
5.
Unity, press play, and woof,
Okay.
that's way too fast. Now you might think that you could just change this move speed
Oosh.
variable to a really small number like 0.001, and that will work, but that's not actually the problem here. You see, code in Update just runs as often as it can. In fact, if we check the stats in Game View, we'll see the game is running at over 1,000 frames per second. Sorry, PlayStation 5, 120 FPS? That's got nothing on Fluffy Bird. And the real problem is that the game may run at different speeds on different computers, and we don't want the pipe to move faster or slower depending on your rig. Real games have actually made this mistake. In Dark Souls 2, weapon durability was once tied to frame rate, so your swords would break twice as fast at 60 FPS compared to 30 FPS.
That I did not know either.
That was a whoopsie. Luckily, it's a pretty easy fix. We just multiply it by time.delta time. This ensures the multiplication happens the same no matter the frame rate. We didn't need it for the velocity code because physics runs on its own little clock, but otherwise we will need it. If you want to know more about this or anything really, the Unity docs are a good place to check. You'll find info and sample code. Okay, now with that fix in place, our pipe moves smoothly across the screen. Lovely. Next, we want to
I
create
actually want to check that. Unity, when adding to velocity, do you need to use delta time? Should be used, but the rest of the resulting will same if sign from update, so they don't need to use time. Hey, try this. Speed. What all those if? You don't use time delta with rigid body velocity. The fact that it already moves your character at a speed that is frame rate independent using actually breaks things. It actually becomes frame rate dependent due to your velocity simply being speed times delta delta. So just set the rigid body equal to that, and it should work just fine. Use those gamers want to do dual controls. Nope. If it is physics based, use fixed update. Feel free to use time delta. That's used to alter time scale slow motion. Time.time scale also alters velocity without using time delta in any way. Check it out. Just change time scale without. Dude, I love these forums too, because there are always people arguing in it. It's so funny. 9 years later. Velocity actually uses time fixed delta time, not delta time. Still, the result will be the same, making your velocity frame rate dependent by multiplying by that. You don't need to use fixed update to change your velocity either. Velocity automatically runs on fixed frames, regardless of when you change it. Correct. It says 9 years later. Look at this guy, bro. He came in 9 years later, Rajdeep 100, and said, correct. That's awesome.
System that will continually spawn
Alright, sick.
new pipes. To start, take the parent game object from the hierarchy and drag it into your project. This creates a prefabricated game object, or prefab. This is like a blueprint for a game object, and we can create new versions of this entire game object. Next, we want to create a system that will continually spawn new pipes. To start, take the parent game object from the hierarchy and drag it into your project. This creates a prefabricated game object, or prefab. This is like a blueprint for a game object, and we can create new versions of this entire game object with all of its children, components, and properties. Oh, and before we move on, we can delete the original in our hierarchy now. Bye-bye. Let's make a new game object called Pipe Spawner. We'll put it just to the right of the camera, and we'll make a script for it. The purpose of this script is to spawn new versions of the pipe prefab every few seconds. And because the pipe already has code to move left, the pipe will automatically move across the screen as soon as it spawns in. We're going to write some code to spawn that prefab we just made. So we'll start by...
Sorry, what
let's
did you do
make
here?
a new game object called Pipe Spawner.
I see.
We'll put it just to the right of the camera, and we'll make a script for it. The purpose of this script is to spawn new versions of the pipe prefab every few seconds. And because the pipe already has code to move left, the pipe will automatically move across the screen as soon as it spawns in. We're going to write some code to spawn that prefab we just made. So we'll start by making a reference to the prefab. Up here, we'll type public game object pipe. Then in Unity, we'll use the same drag and drop method to fill the slot, but this time, instead of a component, we'll drag the prefab from the project panel. Now, Unity has a nice built-in method for spawning new game objects. We'll type instantiate and then open the brackets. In here, the command is asking for some extra details. We can actually flip through these to find different, I don't know, recipes, I guess? Number 4 looks good. It will create an object that will specify position and rotation. So for the game object, we can type pipe. For position, we can just type transform.position to get the position of the object holding the script. That will make it spawn on top of the spawner. And for rotation, let's just use transform.rotation, so again, it's the same as the spawner. Let's run it, and oh my god, that's not what we want. Spawning works great, but they're coming out every single frame, and we want them to come out on a nice interval that we can control. So, back to Visual Studio. What we're going to do now is write some code to make a timer. This will count up for a specified number of seconds, run some code,
There's a coroutine
and then
here.
start the count again. To do this, we'll need to make a couple variables. A spawn rate is how many seconds it should be between spawns, and then a timer is the number that counts up. We can make this one private, as we won't be changing it in the editor or anywhere else. In update, we'll do another if segment. This time, if the timer is less than the spawn rate, then we want to make the timer count up by 1. So we'll take the timer as it currently is and add time.delta time to it. This creates a number that counts up every frame and works the same no matter what your computer's frame rate is. We can actually shorten this by changing it to plus equals, but don't feel like you need to make your code as short as humanly possible just to avoid getting snippy YouTube comments. If timer equals timer plus is easier to read and grasp, then that's absolutely fine.
Very true point.
When you feel more confident. Now, before I said an if statement is like a gate, and we can add another gate to the side of it with else. This means if the condition isn't met, then skip the code and do the code in else instead. So we'll put the spawn code in here, and also reset the timer to 0. So now, every frame, it asks if the timer is less than the spawn rate. If it is, then count the timer up. If it's not, i.e. the timer has actually met or exceeded the spawn rate, then spawn a pipe and start the timer again. Put this in Unity and pretty good. I'm happy with that. The only problem is, we have to wait ages for the first pipe to spawn. It would be good if this came out immediately, right? Now we could copy and paste the spawn code into start, so it happens once in start, and then happens over and over in update. But that's a bad idea. you should generally try to avoid having the same or even similar code in multiple places. What happens if we want to change how the spawn works? We'll have to find and change it everywhere. No good. Instead, we can put the spawn code in a new function and just run that function. So here, a low update, but above the final curly bracket, will make a function called void spawn pipe, and then cut and paste the instantiate code into there. Now we can just write spawn pipe with empty brackets in both update
Okay.
and start. This will run all the code in that function when these lines are executed. And with that done, it will make a pipe as soon as the game begins, and will make new pipes every time the timer maxes out. Perfect. However, this is a pretty boring game, right? And the timers are executed. And with that done, it will make a start. This will run all the code in that function when these lines are executed. And with that done, it will make a pipe as soon as the game begins, and will make new pipes every time the timer maxes out. Perfect. However, this is a pretty boring game, right? The pipes always come out in the middle. We want them to come out at random heights. So remember that when we wrote the instantiate code, we had to pick a position for the object to appear? We'll change that value. Right now, the pipes always spawn on the same position as the spawner. We want the x value to be the same, but for y, we want to pick a random point, somewhere above or below.
In
the
Unreal,
spawn.
that's Z.
So let's create a public variable for a height offset, maybe 10.
This is what I was talking
And
about
then we'll make a
earlier.
float called lowest point. Because we're making this variable inside the function rather than at the top of the script, it means it can only be used within the function. But it also means we can set it by doing a calculation. So we'll do equals transform.position.y minus height offset. And then we'll make another one for highest point, but this time it's plus height offset. That gets us these two numbers. Then we'll replace the transform.position in our instantiate code. We're going to write new vector 3. We have to write that whenever we're specifying our own numbers for a vector. And then in brackets, we'll specify the x,
Right.
y, and z values as 3 different floats. For x, we want this to be the same as the spawner, so we'll do transform.position.x. But for y, we can do random.range, and in the brackets for that, we can supply a minimum and maximum point to pick from. That's lowest point and highest point. Then a 0 for z, and close the brackets. Back in Unity, nice! The pipes will spawn anywhere between these two numbers. Oh, one last thing. Every time these pipes spawn, they'll appear and move left forever, which isn't great practice. They're off screen and doing absolutely nothing, and yet they're still in memory and running code every frame. And if too many spawn, they'll start to spill out the side of your monitor and make a right mess of it. So let's fix that. Now we could make
I like this guy, he's
and
funny.
delete the pipe after a few seconds, but instead we'll check the x position of the pipe and delete it if it goes past a certain point. We'll borrow the bird to find out the x coordinate of the left of the screen. Looks out minus 45. In the pipe move script, we'll add a float for a dead zone, minus 45, and then a simple if statement. If transform.position.x is less than dead zone, then destroy the game object that holds this script. Run it in Unity and bam, they're dead. Let's do one more thing, just as a teachable moment. Just before the destroy line, let's write debug.log and then in brackets pipe deleted.
Okay.
Then back in Unity, you'll see one other panel I skipped during the UI demo. It's a tab next to project called console.
Debug.log.
Then when we run the game, every time a pipe is deleted, our message is sent to the console. This is a wonderfully useful way to debug our code because we can find out exactly what the code is up to. Recap time. Game objects can be turned into prefabs by dragging them from the hierarchy and dropping them into the project. You can then drag
It's actually a really good
scenes.
video.
I use prefabs to create
Should I start with
levels
this
in a
first?
puzzle game, for example. Or you can make a spawner to instantiate means. I use prefabs to create levels in my puzzle game, for example. Or you can make a spawner to instantiate new ones during the game. Timers are a great way to make code happen on a certain interval, but always use time.delta time to keep things consistent across different computers. If statements can have an else gate to make code fire if the condition is not met. You can also have else if to make it more complicated.
By the way, what delta time is the frame. It's the time between the frame now and the last frame that was shot. That's essentially all it really is.
And you should try to delete game objects if they're no longer needed to free up memory. Okay, our next step is to keep track of the player's score and show it to the player on the user interface. Then we want the score to go up by 1 every time the bird goes through the pipes. So remember that a game object doesn't have to be a physical thing in your game world like a character or an enemy. It can be a completely invisible manager that's just keeping track of critical data like health or time or score. And then we can make that information visible to the player using a user interface. So let's start by making the UI.
Okay.
Like everything else, it's a game object in the hierarchy. This time go down to UI and pick text, which may be under legacy. We'll need to zoom really far out on the scene view to actually see the UI. To make sure the UI
Jesus.
looks the same on every device, we'll pick this new canvas game object and set the canvas scaler component's UI scale to scale with screen size, and choose a sensible reference resolution. I'm going to use 1080p again. We can then move our text around. You'll notice that UI has a rect transform rather than a normal transform. The most important thing to note is that you don't really want to mess with the scale of elements, instead change the width and height. I'll then increase the font size and set the default text to 0, and then check it all looks nice on the game view. Okay, now we want to make a script that will store the player's score and change the number on the UI
Nice.
to that score. We'll make a game object called Logic Manager, and we'll give it a script. This script is going to keep track of high-level information like the player's score, and it will have various meta-level functions that we can run. So we'll delete start and update. We don't need them in this script. We can always add them back later if we change our mind that we can run. So we'll delete start and update. We don't need them in this script. We can always add them back later if we change our mind. We want to store a number for the player's score. This time we don't want a float because we only ever want round numbers. So let's do an int instead. That's an integer, no decimal places. And because we want to update the
I'm thinking, I'm cooking right now. So, when we want to do like an on-player collision, you can be like, hey, when a collision happens, there should be on the collider probably like a broadcast thing.
UI text we just made, we will, as always, have to make a reference to it. Except text doesn't seem to be a thing. Well, by default, a script only loads in stuff you need for basic Unity functionality. But if we go up to the top and type using unityengine.ui, we can now access more functionality, in this case, UI stuff. Now we can make a reference to text. We'll need to drag the text component into this field back in Unity. Because we're referencing a component on another game object, the text on the UI, the best way to do this is to just drag the whole game
This
object
is so
into
funky,
our
man.
This will automatically find the text component for us. And
Like,
so
a part of it feels a little bit jank coming from Unreal Engine. You're like, oh shit, okay.
now we want to make a function, and we'll call it add score. And because we're going to run this function from other scripts, we'll set it to public void. This function needs to do two things. Add 1 to the player's score. Easy enough, we know how to do that now. And change the text on the UI to be this number. Oh, the text box is looking for a string, a sequence of characters, and our score is an integer. They look identical to us humans, but robots are fussy. Easily fixed, mind you, by adding .toString to the game score. To make sure this works, let's give easily fixed, mind you, by adding .toString to the game score.
Right.
To make sure this works, let's give ourselves the power to run this function from Unity itself. All we need to do is write context menu and a name above the function. Now in Unity, while the game is running, hit the little dot on this script and pick the function. Nice. This sort of thing comes in real handy for testing. Okay, so now that we know the function runs, we specifically want to run it when the bird goes between the pipes. And the way to do this is collisions.
Yeah,
Now,
that's what I
if
wanted
two
to do.
objects have colliders, they will bash into each other. In fact, in our game, the bird will already crash into the pipes because
Boing.
we've added colliders to both. However, you can also have invisible colliders called triggers. They don't create an actual collision, but they do let you know that two objects have touched, and you can run code at that moment. So we're going to put a trigger in between the pipes, so we know that the bird has passed through them, and then at that moment, we'll run add score. Let's open up the prefab for the pipes. We'll make another game object called middle, and it needs a box collider. Let's make it this sort of shape, and this time we'll tick the box is trigger. Finally, let's add a script to this new middle game object. Beneath update, type onTrig, and the autocorrect will help us type out onTrigger enter 2D. Just press tab to autofill.
That's what it
Anything
is.
in this
Nice.
function will run whenever an object first hits the trigger. There's also onTrigger exit and onTrigger stay for future reference. And it's in here that we want to run the add score function that we wrote earlier, except, once again, this script doesn't know about any other scripts in the game until we make a reference to it. So we can write public logic script logic. But back in Unity, you'll quickly realize that you can't drag the script into this slot. You can't drag it from the project panel. We can only talk to an instance of a script that lives on a game object.